PPT. Nested interrupt handling. So can you read that? So it is a nested interrupt handling. Another interrupt to occur within the current handler. Okay. So yes, nested nest is another interrupt. No? Synchronous code has to be executed without disturbing process. So this is in complexity, which means that designers have to efficiency. So of course, it is given by the interrupt. So it can be like that because it is already interrupt starting from the one interrupt. So again, if you are going to enable another interrupt, so that you is okay. So if an interrupt occurred after the execution of the instructions, DL instructions. So here the nested interrupt handlers. So features will be handles multiple interrupts without priority assessment. Okay. So it has to multiple. The simple difference between the priority and the nested is here without priority assignment. So nested type is without priority. Prioritize to one. Okay. So the only difference between nested and non-nested is enabling the interrupt. So the difference is enabling the interrupt. Okay, so so it has multiple interrupts without priority assignment. So medium to high interrupt level. It is possible of interrupt level, and then I can enable interrupts before starting the interrupt is completely in the interrupt latency. So it is one advantage. You can enable interrupts before the servicing individual interrupt. It is clear during and reducing the interrupt. So disadvantages is it does not handle so disadvantage cannot handle the prioritized interrupts. Unlike priority interrupts can block higher priority interrupts. So this is one of the disadvantages. You can find a difference. Okay, so yeah, it is enabling the interrupt. So after that process, it will complete the first next will connected. So in addition to that, it again interrupt has been enabled. Okay, so within that interrupt has been enabled. So it is enabling the interrupt, re-enabling the interrupt again. So this is so it will give a priority. Okay, priority. Okay, so the so on purpose. So next one, the nomenclature. Okay, so the nomenclature. The nomenclature, the naming. So naming the versions which is in. Okay, so this is the which represents the ARM family. So advanced risk machine. So it is run around so the family. Okay, so and the memory. Okay, so memory management and protection unit. So then the third one is the cache. So what type of cache is used? Which is the memory which sits between memory and CPU cache. Okay. And then T, which is representing the thumb mode, that is 16-bit. So basically, ARM is 32-bit. So if it is operated in thumb mode, okay. So the version has ARM 7, version 7 TDMI. Okay, so TDMI. So it is one example here. The T which refers to as thumb mode. So it can operate in 16-bit mode. Okay. So it is a D which stands for JTAG, which is debugging. It is described by IEEE 494 equipment. So this is the usage of JTAG. Okay, and then M which represents is one of the components of architecture. So then it is I represents embedded IC processor. So the item is a debug hardware. So it is a debugging hardware built into the processor that and watch points to be set. So you can find out in the cage version. So you can so you can based on that processor. So if you are so after that building all the steps, you can find after running the program, you find the breakpoints, watch points. So with the help of that debug hardware, so so you can use watch that is breakpoint and watch points. So you can stop wherever you can break the program wherever you want to know that particular step. Okay, so this is the use of the breakpoints. E enhances, that is E represents the enhanced, which assumes the TDMI. So and J is state, so which is represented in the CPSR program.
Sir, voice break ஆகுதுங்க sir.
So the CPSR and SPSR. கேக்குதா?
நடு கண்டினியூஸா பேசினா
Hello.
voice break ஆகுதுங்க sir.
Okay, so the Jazz state which represent 8-bit processing. Okay, and also F which is represented the uh, uh, floating point and yes, is for synthesizable. Synthesizable means that processor is supplied execute the particular unit. Okay, so particular. Okay, next one is the ARM processor families. So far we have seen that nomenclature. So the ARM revision, first revision ARM V1. So ARM 1, which is a first ARM processor. Okay, the version 1 is a first ARM processor. So it is a 26-bit addressing type. Okay, so and it has 32-bit multiplier and 26-bit addressing. So second ARM version 2. So version 2 is having a 32-bit multiplier. Okay, so and then 32-bit co-processor support. So on ARM version 2A, okay, so it is an ARM 3. It has on-chip cache and atomic swap instruction, and then co-processor, which is for cache management. Okay, so on the ARM version 3, so it is this is the core implementation. So it is the revision. So don't confuse with this one. Okay, so it is a version that is a revision. So it is the core implementation. So it has ARM 6 and ARM 7 DI with the 32-bit addressing, and it has separate current program status register and status program register. So it has two modes with this. In addition to that, undefined instruction and abort. So memory management unit with having a virtual memory, and then ARM version 3M. Okay, so it is having a ARM 7M core, which is signed and unsigned long bit multiplying instruction. Okay, so ARM version 4, it is having a strong ARM. So this is ARM core is called as strong ARM. So it has load and store operations for signed and unsigned off words. Okay, so off words and off bytes. So and it has a new mode, mode, and it has a reserved software interrupt space for architecturally defined operations. Having 26 addressing mode, which is not supported. And then on, so this is a thumb mode. So it can process 32 16 bit. Okay, so next ARM version. So we has ARM instruction and faster multi. So the ARM processor that is developing one have a certain advantage. Okay, so ARM version TEJ. So with Java acceleration. So Java acceleration. 470 and ARM 926E. Code. Include multi-processor instructions and unaligned mixed Indian handling, and then new multimedia instructions. Okay, so these are all the versions. So the family attribution. Okay, so it is a attribute which has the comparison of so it is these ARM core. Okay, so the position is different from ARM core. Okay, so based on that, we are giving the parameters such as pipeline concept with the pipeline depth, operating frequency, so and then power, and then the megabits. Okay, so bits per second, and then architecture type of and multiplier. So what is the different types of so the ascending number which equates to an increasing performance. So comparing to ARM 7, ARM 9, and ARM 10. So once the increase in which equates the increasing performance of the application. So we compare and within these the piping the stage is having around 7 is around 7 having 3 stage pipeline and ARM having 6 stage with the increased in ARM core. So stages, so each stage also increased. So here that operating frequency, so 80 megahertz, and here the 150 megahertz, and here that 260 megahertz, and here 335. Okay. So here the power consumption. So it is 0.06 milliwatt per megahertz. So here it is having 0.19 milliwatts. Okay, with in addition to that catchy. So here the number of bits which is transferred per with respect to that. Uh, uh, so here a number of instructions which is processed with respect to stack 97 and here the 1.1. It is a little bit low compared to 10, 1.2. architecture, human 11 is using hardware architecture where so it uses one human program memory, data memory. So the multiplier which is used is 8 into 32. So here I'm using a 16 into 32 bit multiplier. Okay. So this is the ARM family contribution. So it's having a 32 step store architecture. Okay. It has a conditional execution which uses 3 address format. So like add yes, it represents the register and the value. Okay. So the thumb mode, okay, thumb mode is 16-bit processing instruction, and it also supports load store architecture and unconditional branch. There is the branch instructions and use type. Okay, so it is used add with R1 register 1 and then with a value. Okay, so JASL instruction, it has 8-bit instruction. So it is executing a Java byte code execution. So it is using a Java byte code execution. So this family attribution, ARM which continues to expand with the both number of which architecture, first one architecture is having a one human architecture. Okay, so instruction architecture description. So mnemonics. Mnemonics. So which is sorry. So understood by human being. So it is equally, that is it is converted into output. Okay, so ADC has encoders in assembly. So ADC is having the two 32-bit values and with a carry. So carry will be the 33rd bit will be the carry. Okay. So and then next is add. So add version 1 with that add 32-bit value. Simply adding the two 32-bit values. The bitwise and the operation. Okay, so here the bitwise and the operation. Okay, and then which is B, which is a branch. It represents the memory. Okay, so BAC is a bit function. Okay, so B it is a break. Check program starting give the pause. So it is like a pause with any other branch. So branch is a BX stands for so here the BX which is meant for branch with exchange. For version 4T. And CDP is a co-processor data processing operation, and then CL is count leading zeros, and then CM which comparing the two negative values. So N which stands for comparing two negative, and CMP is compare, which is normal comparison with. So and then EOR, that is exclusive or 2 bits. LDC is to co-process single or multiple 32-bit values, and LDM multiple bits from memory numbers. So LDM is from memory to register. Value from MC2. So it is a from ARM register to other register. So MR the 32-bit and MOV, that is a move register. Okay, so here the MRC stands for move to ARM register or register from a co-processor, and MRS register from a status register, CPSR or SPSR. The MSR is move to a status register from ARM register. So MUL which multiply to 32-bit values, and MVN which more than a logical not of 32-bit value into a register, and ORR which is a logical bitwise OR operation. and PLD is a preload hint instruction, and QAD is a signed saturated 32-bit addition, and QDAD is a double addition. Okay, so signed saturated double with subtract. Okay, so double with and 32-bit subtract, and this is 32-bit add. So it is Q sub is a signed saturated 32-bit subtract. And RSB is a reverse subtract of 32-bit values. So RS is the reverse subtract with carry of 232 bit integers. So SBC is meant for carrying of 32 values, and SM in AL, so it is accumulate long. Okay, so long is the 32 into 32 bit with 64 bit. Okay, then SM multiply accumulate long with 64 bit. Yes, 60 to 60 bit. Okay, SM maybe XY. And then multiply accumulate 16 bit. So here it is signed multiply long with 32 bit. With 32 bit. Okay, so on the 16 bit and 32 bit. The STC is stored to a single memory, and memory single or multiple 32 bit values, and STM is storing a multiple 32 bit registers to memory. So here the STR is store the register to a virtual address in memory. SUB is subtracting up to 32 bit. SWI is software interrupt. SWP is a swap a word in memory with the register without interruption. Okay. So DEQ is a test for equality of 32-bit values, and TST is a test for bits in a 32-bit value. So here the unsigned multiply accumulate long, which is a 32-bit, and unsigned multiply long, which is having 64-bit. Okay, that's all about today's session.